Hi.
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 We're Tomorrow Lab,
An invention studio focused on new hardware technology.
We create prototypes
and then turn them into market-ready, manufacturable products.
With the help of our potentially genius guests
and our friends at Digi-Key,
We turn a potentially genius idea into a prototype of a potentially genius thing.
all while giving you a peek into our 4-phase invention process.
In this episode, our guest is Carla Diana. Carla is a product designer, engineer, author, and educator who is the creator and director of the 4D design program at one of the country's oldest design schools, Cranbrook Academy of Art. Her latest book is titled My Robot Gets Me and is about how to make robots and smart products more human through creative uses of light, sound, movement, and sensing, all of which are great prompts for a potentially genius thing. So, what is your potentially genius idea?
One of the things that we had talked about a little bit that I've been, daydreaming about some more was the microphone, the simple microphone. So I'm thinking about that moment when someone goes up to the stage and they do this, hey, can you hear me now? Am I too low? Is this right? Wait, hello? So how can we have that whole interaction just happen as a social exchange where the mic itself says, hey, I see you. I'm listening to you. You're the speaker. Let me point towards you. I'm adjusting my height.
A robot mic stand would also be really cool if you lean in and it comes and says hello. It just meets you halfway.
Here, I'll try it. So, and now it turned on. So,
So I'd be like,
this is video prototyping.
sorry, I just had to shout at my children. All right, so this is really fun. We're going to make something
This
genius.
was a blast.
I'm sure of it. I'm pretty pumped about it. Ted, you pumped?
I'm super pumped. Carla, you pumped?
I am extremely pumped.
We are going to get on this right away, and it's going to be good.
I can't wait.
Okay, so our brief was to create a microphone that uses gesture sensing and movement to respond to the speaker's body language and provide a better user experience. We brought in Jason and Pepin to work on this project, and together we explored a few approaches, like LED indicator rings for microphones, gesture sensing gloves for muting or unmuting your microphone, and even a robotic microphone that rolls around on your desk. We also looked at Digi-Key components, like this really cool motorized potentiometer, and figured out a rough concept and schematic for a motorized microphone that senses your body language. Our final concept is a desktop microphone that changes its position and mutes and unmutes your conference software based on how you lean in or lean out from the microphone.
We'll have an Arduino that's connected to a laptop through an HID interface. So whenever it presses the button virtually, the computer will detect that press. So the potentiometer, it's moved along the track. It should also send a signal back to the Arduino so that we will know the position of that motor. Right?
So to demo it really quickly, you lean in, a sound wave bounces off of your body, comes back to the device. The device recognizes that shorter distance, and then it's going to say, okay, Jason's trying to talk, and then our potentiometer is going to slide. You're going to link it, just going to bring the microphone to meet Jason's face. He can talk, blah, 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 blah. And then when you lean back, we sense that you've moved away, and this will go, phew, and simultaneously it will mute the computer.
Right, that's how it works.
So now we need to order the components, start breadboarding, develop the mechanism, and start prototyping.
To get going, we went to our friends at Digi-Key and ordered a couple components: a perma protoboard, a SparkFun Pro Micro, an ultrasonic sonar distance sensor, and our secret ingredient, the Born motorized potentiometer.
So our slider thingy moves 100 millimeters back and forth. Looks like that. So that's about how much it's going to move. And we're going to attach it to an arm that's going to make it go like this. Shoop, 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 shoop. And so before I do any of that, I want to just mock it up super, super quick. And once we validate that, then we can bring it into CAD. All right, so here's our mechanism right here. Here it is. It's off. It's far away. You can't hear me very well. I know, it's a bummer, but then I lean in, I lean, it goes, oh, hello, friend, and then you can talk into the microphone, and it is great. Hello, goodbye. It is good. It's cute.
Right after receiving the potentiometer, we realized that there's no built-in motor driver, which means that we can't drive the motor backward easily. To make that happen, we have to build an H-bridge motor driver, which essentially allows us to reverse the polarity and drive the motor backwards.
So if I tie the left two MOSFETs to Arduino pin A, the right two MOSFETs to pin B, and set pin A to low, pin B to high, these two MOSFETs are turned on, current flows like this, and motor spins forward.
Now I've got the electrical system working. Now Pepin can start designing the housing for it.
So we've prototyped the mechanism to some degree. We know that we can create this great expansion using the slider. But the question then becomes like, well, what is it, right? What is the concept of our design? I was thinking about this problem, and I was out for a run, and this great blue heron flew overhead, and I grew up on a marsh, and I'm very familiar with this bird. It's a sort of a beloved animal to me, and my favorite thing about it is it can be completely disguised in a marsh, and then it'll stick its head up, and it'll open its enormous wings, and it'll spring into the air, and it becomes this big bird, very conspicuous. So it goes from inconspicuous to very conspicuous, and I thought, well, that's a great concept of what we're doing. And so using this metaphor of the crane was really fun, and so I'm going to sketch on that and see where I get to. Now that we know what our design concept is, it's time for me to do just a bunch of CADs. I'm going to be CADing up all of the individual pieces of this. I've come up with a rough sketch so that way I'm not sort of like surprised about, you know, oh, I need this piece or that part. I know what I'm building, so I'm gonna make all of those parts. I'm gonna put together an assembly in SolidWorks, and I'll be able to test the motion out in that as well. We have these things all laid out in CAD. Now we gotta bring it to print and assemble it, and hopefully it's all gonna come together because we've got our presentation coming right up.
So 3D printed housing is assembled, integrating the electrical system into the housing. I'll debug the entire system all at once and get it ready before the final presentation.
Hey, Carla, welcome back. We're super psyched to have you.
I'm excited too.
We've been working for a few weeks on a potentially genius idea. We're just like really excited to show you.
Yeah.
So I want you to meet the bird.
Wow.
The design centers around an Arduino Nano, and that controls the sensing and the interaction. There's also an H-bridge on board, which controls the motion of the potentiometer. Then we have hidden in the front this ultrasonic rangefinder, and that senses how far away your body is and starts the interaction as you draw closer. Then there's a lavalier style microphone, which is used to record your voice and also works really great to block out background noise. Lastly, we have this cute little microphone cord going across the top, and we size that just right so when the head comes up, the microphone cord gets short and the head tilts up at you. And we think this is a really fun piece of the interaction.
And then also we wanted to be able to actually mute and unmute software, and we found conveniently that most of the popular, web conferencing softwares like Zoom and Hangouts, they all have keystrokes that we could mimic through an Arduino keyboard profile and literally be able to, mute and unmute the software when you interact with this bird.
The motion is really cool. It really gives you the sense of something that's becoming alert and listening. Oh, look at that. Yeah. It's magic.
It's like coming up to give you a kiss.
Yeah, I know.
So cute.
It's really lovely. Yes? What's that? Yeah, I can't get over this. This gesture is really powerful. It really feels like an entity that's listening or sitting back.
So Carla, I'm going to ask the question, did we create something potentially genius here?
It's hard to say definitely with potentially in the same sentence. Definitely genius. It's so gestural and so communicative. And thank you so much for making me part of Potentially Genius. I'm really loving this.
It wouldn't be Potentially Genius without you, Carla.
Aww.
Great. All right. Thanks, everybody.